Imagine a single missile, silent but deadly, streaking across a war-torn sky. Behind it are American engineers, GPS signals, and millions of dollars of work. For Ukraine, this weapon is a lifeline. It can stop a tank, clear a path, and save lives. Without it, front lines would collapse. Today, we go inside how America builds, ships, and fights with its most powerful defense weapon for Ukraine, and why every piece matters more than ever. When Russia invaded, Ukraine needed help fast. A few rifles and helmets were not enough. They needed big guns, smart rockets, and strong shields. America pledged over $175 billion in aid. That is more than the cost of the first 4 years of war in Afghanistan. It includes tanks, drones, body armor, even air defenses worth $1 billion each. But among all these gifts, one system stands out: the M142 High Mobility Artillery Rocket System, or HIMARS. Each HIMARS launcher can fire missiles up to 43 miles away with pinpoint accuracy. They can strike enemy positions, ammo depots, and command centers without warning. For Ukraine, HIMARS changed the fight. It turned dead ends into open roads and held back Russian advances. Before HIMARS arrived, Ukraine used old Soviet artillery and rockets. These were heavy, slow to load, and not very accurate. Shells sometimes missed by hundreds of yards. Soldiers faced danger every time they moved a gun. Then HIMARS came. A truck-based launcher can load 6 rockets in minutes. It drives, fires, and drives away before enemies can shoot back. Just one HIMARS launcher costs about $8 million. Each rocket costs around $100,000. That may sound like a lot, but a single rocket can destroy a fuel depot or a bridge, saving lives and stopping enemy attacks. American factories had to ramp up to meet the demand. Before the war, HIMARS production was slow. Now plants run day and night. In a factory in New York, steel beams and electronic boards come together to form a HIMARS chassis. Workers bolt huge tires and a crew cab onto the frame. Inside, computers and guidance systems are wired in. Each part is tested for leaks, cracks, and faults. The launcher arm goes through dozens of checks. If a weld is off by even a fraction of a millimeter, the rocket could miss its target, or worse, explode too soon. Meanwhile, at a plant in Texas, technicians assemble the rockets. They start with a steel tube called a motor casing. They fill it with solid propellant that burns evenly for seconds. A warhead filled with explosives and shrapnel is attached at the front. Then comes the guidance section. Tiny gyroscopes and GPS receivers fit in a ring near the warhead. Computers inside ensure the rocket stays on course, even if the wind blows or the launcher wobbles. After assembly, each rocket is tested in a cold chamber to see how it works at freezing temperatures. Then it is warmed and tested again at high heat. Cold or hot, HIMARS rockets must fly straight. One bad batch could be the difference between victory and defeat. Once tested, rockets are packed in sturdy crates and trucked to a port. Soldiers load them onto ships bound for Europe. From there, they travel by rail and truck to Ukrainian bases. The journey takes weeks, but Ukraine needs them now. Every delay can cost lives. Back in Ukraine, crews learn how to use HIMARS. The US sent trainers to teach soldiers how to aim, load, and move the launchers. It takes about a week to train a team of 5. They learn to read maps, lock on GPS, and fire in all weather. At night, they practice under floodlights. When the time comes, they must fire and leave fast. HIMARS crews work in pairs. One soldier drives the truck, another sets up the launcher on the ground. A third loads rockets, a fourth reads coordinates, and a fifth records each shot. They call out distances and targets. In minutes, they can fire all 6 rockets. Then the truck rolls away, leaving no mark on the earth. The impact of HIMARS on the battlefield has been huge. Ukrainian generals say it forced Russian troops to hide in bunkers and dugouts. They had to move their artillery farther back, slowing their fire. Bridges and ammo stockpiles melted under the precision strikes. Roads once swarmed by tanks became empty. But HIMARS is not the only American gift. Early in the war, the US sent 10,000 Javelin anti-tank missiles. Each Javelin costs over $200,000. A soldier presses a small screen, locks on the weakest spot on a tank, and fires. The missile climbs and strikes from above, where armor is thinnest. Tanks that once roamed free began to fear open fields. Alongside Javelins came NLAWs, next-generation light anti-tank weapons. They cost around $40,000 each. Soldiers carry them on their shoulders like a long tube. Aim, fire, then find cover. No heavy crew or big vehicle needed, just a trained soldier and a missile. To protect these soldiers, America also sent 100,000 sets of body armor and helmets. Each set can cost up to $2,000. They block shrapnel and bullets that would kill or maim. Night vision devices let fighters see in the dark. Thermal scopes show heat from engines or troops. These tools turned night into day and gave Ukraine an edge in small fights. The first months of war saw a rush for gear. Factories around the world struggled to keep up. Some plants cut corners to meet orders. Quality dropped. The US tightened inspections to make sure every Javelin, every helmet, and every spare part was safe. Lives depended on it. With winter rains and muddy fields, Ukraine faced new challenges. Snow and ice can jam machines, batteries die fast and cold, but HIMARS and Javelins still worked. Soldiers wrapped wires and screens in blankets. They warmed rockets near fires. American tech proved rugged and reliable. By spring, both sides turned to longer-range guns. When distances grew, HIMARS and artillery shells ruled the day. Ukraine's artillery parks filled with American cannons. The M777 howitzer, a light 155mm gun, arrived from US factories. It takes 12 months to build one howitzer. Its barrel, made from high-grade steel, must withstand fire and stress. Each shell is a testament to foundries, welders, and chemists who shape thin steel into instruments of war. As the fighting drags on, the US continues to send new weapons. Patriot air defense batteries now protect Kiev. They can detect and destroy incoming missiles and planes. Each Patriot launcher is worth $1 billion. Its radar sees threats from hundreds of miles away. Each missile costs around $3 million. But with Russian drones and missiles looming, Ukraine needs every shield. Behind all these weapons are workers, engineers, and drivers. A welder in Ohio, a tech in Texas, and a sailor on a ship all play a part. From steel mills to front lines, America's defense machine has turned hope into firepower. Ukraine's most powerful defense weapon is not just a missile or a gun. It is the link between people, factories, and soldiers who work together across oceans. It is trust between allies and the shared will to defend freedom. And it shows how one weapon can change the fate of nations. From the front lines, let's step back and look at how these weapons come together in American factories, and how each part moves closer to Ukraine. Every launcher and every rocket needs steel. Big steel plants in Pennsylvania and Ohio roll out long slabs called billets. These billets travel on huge rollers that press them into thick tubes. Some tubes become the body of a HIMARS rocket. Others become the barrels of artillery guns. The metal must be perfect, no cracks or weak spots, because it will face heat and pressure when fired. After shaping, the tubes cool in giant fans. Workers check them with magnets and X-rays to find any flaws. If a crack appears, the piece is sent back for reforging. Only perfect metal moves on. Next, the tubes head to the machining shops. Giant lathes spin them at high speed, while cutting tools trim them to precise dimensions. The human guide makes sure each cut is straight. Then a drunk test checks roundness. Pipes roll down a slight slope, wobble too much, and they fail. Perfectly round tubes live to serve another day. For HIMARS launchers, the steel goes on trucks to another plant, where engineers weld the frame, install the engine, and mount the launcher arm. They drill hundreds of holes for wires and sensors. Each weld is X-rayed and ground smooth. The good weld is as smooth as a car hood. Meanwhile, at a missile plant in Utah, workers build the motors. They mix powders of fuel, catalyst, and binders in huge drums, like giant cement mixers. The mix is pressed into long rods that fit inside rocket casings. After a week of slow drying, the rods are cut to length and loaded into the casing. The open end of the rocket is capped with explosive and guiding parts. That guiding kit is a cluster of parts: a small computer, battery, GPS receiver, and tiny motors. These bits steer the rocket after launch. Engineers solder circuits by hand. Then they cover the circuit boards with a thin layer of plastic to keep out moisture. Each board is tested in a jig, a frame with golden pins that check every wire and chip. If one test fails, it goes back to a repair station. Once motors and guides are together, rockets are sealed, painted, and boxed. Then they cruise to a central depot in Texas. There, ammunition specialists sort them by lot number and date. Shells for howitzers are sorted the same way. Each box is stamped with a barcode for tracking. Next stop, the Port of Houston. Massive cranes lift crates onto cargo ships. Each crate is locked, sealed, and logged in with U.S. Customs. Navy sailors guard the docks and watch for anything wrong. After a careful scan, containers are loaded onto a ship bound for Europe. In Europe, they arrive at a U.S. base in Poland. There, soldiers move them onto trucks and trains. The route runs through cities and open fields. Guards ride in the cabs to keep watch. Each convoy has decoy trucks in case of attack. At night, drivers stop at secure bases. Each driver sleeps in a locked tent. At dawn, they set out again. When the weapons reach Ukraine, military police check each crate. They scan barcodes, open boxes, and count every rocket and shell. They mark off lists on tablets and send receipts back to the U.S. supply office. Only then do the weapons move to military stockpiles. From the stockpiles, units request what they need. A battalion commander might ask for 100 rounds of 155mm shells and fuel for their trucks. Quartermasters fill out forms on tablets. Then trucks roll out, often at night, to hidden artillery positions. Drivers know that a single shell can tell an enemy to stay in their trench. Alongside these big weapons, many small parts matter too. Spare batteries, radios, night vision goggles, and even zip ties all move along the same route. If a bolt goes missing on a launcher, it can freeze the whole system. That is why logistics is a battle all its own. The U.S. Army's 405th Army Field Support Brigade runs convoys, tracks wear parts, and sends teams to fix broken gear. To keep HIMARS ready, soldiers in Ukraine learn basic repairs. They change tires, tighten wiring, and replace burned-out bulbs. For bigger fixes, U.S. civil engineers fly in. They carry toolboxes with drills, welders, and spare valves. A broken launcher arm or a bad circuit board is swapped out in hours. Training Ukrainian soldiers is key. At bases in Germany, U.S. trainers teach them to drive, fire, and reload. They practice with blank rockets before using live ones. In summer heat and winter cold, they learn how HIMARS reacts to weather. They also drill how to quickly hide the launcher and avoid enemy fire. Back in America, the Pentagon watches every step. Every shell sent is tracked from factory to front line. If losses rise, the U.S. plans to build more. Congress sets budgets. Additional funds mean new factories and more workers. To meet this, private industry ramps up. Contractors hire welders, machinists, and engineers by the thousands. They pay signing bonuses, build new plants, and train workers. Locals once laid off by other industries now work on rockets and tanks. They learn skills that can last a career. However, higher production brings challenges. Supply chains stretch thin. Electronic chips, rare earth magnets, and nylon cables are all in demand. Factories must find new sources or risk delays. The Defense Logistics Agency searches worldwide for parts, working with allies. As Ukraine holds the line, the US faces decisions. Should more HIMARS go? Will Ukraine get longer-range rockets? Can Congress agree on more funds? Each question shapes how many weapons reach the front. For now, Ukraine fights with what it has. HIMARS crews patrol hidden positions. Artillery fires in volleys, Javelin teams set ambushes, Patriot batteries watch the sky. Each shot echoes the long supply chain from American steel mills to European rail yards to Ukrainian stockpiles. When a rocket finds its mark, it shows the power of this chain. A single missile is many hands, miles of road, and weeks of work. It is a link between people who build weapons and soldiers who defend a nation. That link is America's most powerful defense weapon for Ukraine. Once the weapons reach Ukraine, the journey is far from over. Trucks roll off the rail cars and head to army depots inside Ukraine. Soldiers unload heavy crates by hand and with small cranes. Each crate has clear labels: what is inside, when it was made, and where it must go next. Inside the depot, staff sort the weapons into piles. Rockets go in one area, shells go in another. They stack them by date so the oldest get used first. This is called first in, first out. It helps keep everything fresh and safe. From the depot, the weapons move to the front lines in small convoys. A convoy might carry just 10 rockets and 5 crates of shells. Soldiers drive in pairs. One drives, the other keeps a lookout. They stop at checkpoints where officers scan their orders. No crate can move without a signed slip. Near the battle zone, teams set up smaller ammo dumps. These are hidden in barns, under tarps, or even inside old cellars. Troops can grab what they need in minutes. This saves time when the guns roar and soldiers need ammo fast. Field soldiers learn to handle the weapons with care. They train on safety first. They learn how to carry rockets so the fins don't break. They learn how to join the guidance wires on HIMARS rockets without touching the tips. One wrong move can send a rocket off course. Every night, ammo teams make rounds. They check each launcher for scratches, dents, or loose parts. They wipe away dust and sand. If they find a problem, they mark it and send it back for repair. This keeps launchers ready for the next firing mission. Meanwhile, back in America, factories keep making more parts. They do this on a tight schedule. If Ukraine needs 1,000 more rounds, the order goes to the Pentagon. The Pentagon sends it to a plant. That plant works extra shifts. They call in all the workers they can. Then they send the parts to another plant for assembly. This can take weeks. To help speed things up, Congress passed a law to ease rules. This law lets factories use more overtime. It also lets them import parts from close allies faster. Now a mold maker in Germany can send parts to Texas in days, not weeks. Even so, some parts still are in short supply. Tiny circuit boards for guidance systems are hard to find. They come mostly from one factory in South Korea. That factory must meet many checks. It sends its boards to the US by air. But airspace is busy. Sometimes flights get delayed. When that happens, US-born engineers must find backups or test boards by hand. To solve this, the US created a chip hub in Arizona. There, they stockpile extra boards. This hub also tests new chip designs. If one design works better, they switch fast. That hub runs 24 hours a day. In Ukraine, engineers also work around the clock. They repair broken parts in field workshops. They weld cracked metal, rebuild small motors, and test guidance systems. When a HIMARS arm breaks, they replace it in a few hours. Old tanks get new parts too. Idle vehicles are fixed and sent back to the front. Nurses and medics also benefit from this support chain. The same trucks that carry rockets often carry medical gear. Bandages, blood packs, and wheelchairs ride inside trucks. This dual load helps keep the army strong. People back home watch this work on the news. They see long lines of trucks in Ukraine or hear about factories in the US. They write letters to their senators. Some want to send more aid, others ask to spend less. This debate shapes the next budget talks in Congress. For now, the US plans to keep funding at current levels. That means more rounds built and more tanks sent. It also means more HIMARS and more Patriot systems. New air defenses arrive soon, with special radars and missiles that can track many targets at once. In classrooms in towns across America, students learn about these factories and supply lines. Some choose to study engineering or logistics. They want to help make the next generation of weapon next supply chain that saves lives. In the end, the story of these weapons is also a story of people working together. Factory welders, transport drivers, depot workers, soldiers, and lawmakers all play a part. Each link in the chain must hold strong for Ukraine to defend itself, and so the journey continues. From steel slabs in America to rockets in Ukraine, each step is filled with care, skill, and a sense of purpose. Every missile fired is the result of thousands of hands, miles of rails and roads, and weeks of planning. This is how America helps Ukraine with its most powerful defense weapon. It is more than metal and explosives. It is a chain of trust and effort that crosses oceans and front lines. It shows how many people can join to protect hope under fire.